So for 0.05, okay, when you come to the table, like I said, these are the probability values down here. And we are going to look for the critical value, which is a Z value. So you come and locate the probability of 0.05. So when we come down here, we are getting 0.05 here, okay, and then 0.049494, okay, or let's say 495. So very close to 0.05. I hope you can see clearly. Hello, class.
Yes, sir.
So when we read the Z value that is giving us these two values, okay, that will be negative 1.6, negative 1.6, and then the second decimal place will be what? This is 4 here, negative 1.64, and then the other value is negative 1.6 what? 65. Okay, good. Now the trick here is, you see, neither of these values is exactly 0.05. Okay, but if you add the two, that will be 0.049495, okay, approximately, okay, and then 0.05, okay, 05, okay. If you add these two and divide by 2, you're going to get exactly what? 0.05, okay, which means that similarly we're going to add these two and then divide by 2. We are adding the Z values and dividing by 2, and that gives us what? Negative 1.645. Okay, good. So what we are saying is, on the, okay, on the graph, the probabilities we've just read, one is 0.0495, and then the other is a bit bigger, 0.0505. So if you want 0.05 exactly, you add the two and divide. So half in it gives you the exact value which we are looking for, which is negative 1.645. Okay. However, let's also take note that the region which we are looking at was a right-handed rejection. Okay. But that does not take anything away. We know that the graph was symmetric. Okay. So if we have negative 1.645, then we can bring it to the right hand, which will be positive what? 1.645. Okay, so let's go back to that example. Okay. Yeah. So what we are saying here is, our critical value is 1.645. Okay. That's the critical limit here. Okay. 1.645. So it means that if we compare the calculated value which we had, which was 6.395, if we compare it on the graph, or we plot it on the graph, That will be far on the right of 1.645. Okay, 6.3 will be far on the right. But we know that the whole portion on the right side is the rejection region. Okay, so if this calculated value is lying in the rejection region, then it means that we have what? We have in evidence to reject what? The claim or the null hypothesis. Let me put it well. So we have evidence to reject what? H naught. Okay, we have evidence to reject H naught because a claim is not always your H naught. So we are saying that the test statistic falls in the rejection region. So H naught is to be what? Is to be rejected. Okay. So we conclude that at a 5% level of significance, there is enough evidence to reject the null claim, which is H naught. Okay. And if we are rejecting the null claim, then what are we saying? Okay, our hypotheses were such. We said H null was what? Mu is what? Is less than or equal to 70 centimeters. And then HA, which is the alternate hypothesis, was what? Mu was greater than what? 70 what? Centimeters. Okay, good. So what we are saying is, if we have rejected this claim, okay, that we have evidence to reject it, then what we are saying is that then the average length of what? Iron rods is indeed greater than what? 70 centimeters. Good. So this is how the analysis goes for the test on 1 mean. Okay, let me take some questions from you before we go to the next example. Yeah, questions.
So no question from me.
Okay. Yeah, then let's continue. So we want to look at the next example. Yeah, so the next example says that the telephone company claims that the average length of phone calls is what? Is 8 minutes. Okay. In a sample of 58 phone calls, okay, the sample mean is 7.8 minutes and the standard deviation is what? 0.5 is 0.5 minutes. Is there enough evidence to support what? To support the claim at alpha of 0.05? Good. So we look at the question carefully again to see our claim, to find out the given parameter. So we go back. It says the company claims, this one is quite straightforward. It claims that the average length of phone calls is 8 minutes. Okay. So clearly the claim is what? Average is equal to what? 8 minutes. Good. Then what again? Once he has claimed that average is equal to 8 minutes, then the opposite statement will be what? Average is not equal to what? 8 minutes. Okay. Which will also mean that because this contains the equal to, the claim contains the equal to, that will be your null hypothesis. And then for the other statement, which is not equal to, that should be your alternate hypothesis. Okay. Then the next step is to state your alpha level, which has been given, okay, as 0.05. The third step is to decide which test statistic to make use of. Now let's go back to the statement. Here we are told that the average length of phone call is 8 minutes in a random sample of what? 58 phone calls. So your N is what? 58. Okay. N has been provided as well, 58. Good. And then the sample mean is what? The sample mean X bar is 7.8. Sample mean is 7.8 minutes. Okay. And standard deviation, we are dealing with a random sample. Okay, so this standard deviation is for the random sample. So, and standard deviation is what? That is standard deviation as sample standard deviation is what? 0.5. Okay, good. And we have been asked, is there enough evidence to support the claim, this claim? Okay, good. So in this question, we can clearly see that the population standard deviation is unknown. Okay, and once it's unknown, like we said, there are two questions you have to ask yourself. There's a question you have to ask yourself because there are two cases. Okay, so you ask yourself whether the sample size is large, and large means it should be greater than 25. Okay, and of course this sample size is far greater than what? 25. Okay, good. So once it's so, then by CLT we can use the normal distribution, which is sets, using the set score statistic. Okay, and that is giving us what? X bar minus the test statistic value mu naught over your X divided by, or S divided by the square root of what? N. Okay, and then once you fuse those values in there, which is what? 7.8, the sample mean, minus the test value, which is 8 here, okay, over the standard deviation 0.5 divided by the square root of the sample size, we should get negative 3.05. Okay, so you can verify that too before we continue. So once you do the calculation, you get negative 0.35. Okay, so once you've obtained this value, the next thing to do is to decide on the decision rule. Okay, where we once again going to use the critical value approach. Okay, and then we said the first thing you do is check the sign of the alternate hypothesis. Here we have mu is not equal to, like we said, can be greater than or less than. Okay, so less than means we have half of the rejection region here, which is alpha on 2. Okay, and then the other half on the right side, alpha on 2. Okay, so if we're going to read this time, we are going to read Z alpha on 2. Okay, alpha has been provided as well, 0.05. 0.05. So divided by 2 will give you what? 0.025. Okay, so we are going to read Z with a probability of 0.025. Okay, very well. So let's go to the statistical tables. Yeah, so once again, we are going to read from the left hand because the probability is less than 0.5. Okay, so when we come here, look at this carefully. We have 0.02499, okay, here, which is approximately 0.025. Okay, the next figure is far beyond that. That's 0.0251, 255. So it is far beyond that. Okay, good. That is far beyond that. So we're going to make use of the value we are seeing here, okay, which is generated as a result of what? 1.96 and then what? 0.06. So we have 1.9, 0.06. So that gives us what? Negative 1.96, okay? Negative 1.96, okay? Negative 1.96. Okay, so let's go back to our example. So which means that we're going to get negative 1.96 like you're seeing here. This is the first limit, negative 1.96. And the other limit will be what? Positive 1.96, okay? So any value that goes beyond this, if it goes beyond that, crosses the negative 1.96 and this, then it means we are going to reject it, right? And then clearly, per the calculated value we have here, okay, if we plot on the curve, we can see that it will lie on the left hand of what? Negative 1.96. Okay, so we are saying that the test statistic falls in the region, in the rejection region. Okay, so H naught is to be what? Rejected, right? So once you've identified that H naught falls in the rejection region, you have to conclude that at an 5% level of significance, there is enough evidence to reject what? The null claim, okay? This time the null claim is also the claim, to reject the null claim that the average length of phone calls is what? Is 8 minutes. Very well. Okay, any question? Any question, class? Question time, class.
No question, sir.
Yeah, other participants.
No questions, sir.
Third example as well. Okay, the very third example on test for 1 min. Okay, then you can try the remaining examples on your own. So for the same telephone company, this time is the same question.